In the last video, we looked at traces, which are the curves of intersection of a quadric surface with planes that are parallel to the coordinate planes. We're going to apply that algebraically in this video in example 1.4.2, where we are asked to name and graph the quadric surface given by this equation, x squared plus 2y squared plus 3z squared is equal to 6. We're first going to do that by analyzing the surface, by examining traces, algebraically this time, because obviously we can't do it graphically if our goal is to graph in the first place. We're going to analyze in the planes x equals k, y equals k, and z equals k for different values of k. So let's start by looking in planes that have equation x equals k, so planes that are parallel to the y-z coordinate plane. And if we go and plug in x equals k quite literally, then we get k squared plus 2y squared plus 3z squared is equal to 6. Bring that over to the other side. 2y squared plus 3z squared is equal to 6 minus k squared. And we recognize here from our review on conic sections, we have two squares, but the coefficients are both positive and different. That means that we have ellipses. We have ellipses in yz, right? So the variables are y and z, every plane parallel to the yz plane, which has equation x equals k again. The cross-section of our quadric surface, the curves of intersection, which are the traces, are ellipses in yz. Now there's more information that we can get actually by looking here. We see on the left-hand side that everything, maybe I'll move this down just a little bit. On the left-hand side, we're summing two positive values. So the left-hand side must be greater than or equal to 0, two non-negative values. On the right-hand side, therefore, this must also be greater than or equal to 0, which gives us a little bit of information on the k values that we can take, how far our surface extends in the x direction. So our restrictions on k, we have that 6 minus k squared must be greater than or equal to 0, which is the same thing as saying k squared must be less than or equal to 6, or negative root 6 is less than or equal to k is less than or equal to root 6. Let's go and look at information in y equals k, so parallel to the xz plane. If we go and plug in y equals k and bring it all over to one side in one step, so we're getting x squared plus 3z squared is equal to 6 minus 2k squared, plugging in y equals k. We again see the same thing. We have the sum of squares with positive but different coefficients. We have ellipses in x and z, right? The variables are x, z. So if ever you forget what coordinate axis you're parallel to, you can see by looking at the variables here. We also have restrictions again. The restrictions on k are that 6 minus 2k squared must be greater than or equal to 0, which is k squared has to be less than or equal to 3, or negative root 3 is less than or equal to k is less than or equal to root 3. And lastly, if we look at planes that are parallel to the xy plane, so planes whose equation is z is equal to k, plugging that in, we're going to get x squared plus 2y squared is equal to 6 minus 3 k squared. Again, we have ellipses in xy, and the restrictions that we have the same way. The left-hand side is positive, so the or non-negative, the right-hand side must also be, which is going to give us that k squared must be less than or equal to 2, or minus root 2 is less than or equal to k is less than or equal to root 2. So now we have that we have seen traces. We've got our traces in all three planes are ellipses. So all traces are ellipses. There was only one of our quadric surfaces that had that characteristic. Our surface is an ellipsoid. And we can go and sketch it, given the information that we have there above as well. So if we give ourselves a set of axes, there's my y, my z's, and my x axes, so x, y, and z. We know how far our surface extends in each case. In the x direction, our surface goes from minus root 6 to root 6. In the y direction, from minus root 3 to root 3, and in the z direction from minus root 2 to root 2. So we have a football shape, right? We have the ellipsoid, which we need to sketch in to the best of our ability. Now your sketches here don't have to be beautiful. It'd be nice if they were beautiful, but they just need to be functional. So I am not an artist by any stretch of the imagination, but we can kind of sketch in what our curve will look like by sketching in the appropriate ellipses. Right, so that is as good as you need to do. That's as good as I can do. You can even give a little bit of shading if you want to here, so that we understand that that is a surface graph. But there's the graph of our ellipsoid that's longest in the x direction. And we've got that by analyzing the traces, the intersections of that ellipsoid with each of the types of planes x equals k, y equals k, and z equals k. In the next video, we'll do one more example of this type, example 1.4.3, and see what the resulting quadric surface is in that case.